In this video, we are doing another example of the mean value theorem. So in my other video on the mean value theorem, we ended up with f prime of c, so the slope of the tangent line of the point C equals a constant, which just means a number by itself. It's not associated with any variable. So in this video, we're going to talk about when the slope of the tangent line on the point at C doesn't equal k, which is what you'll see probably most of the time when you do these questions yourself. So I think we'll talk first about what the mean value theorem means and where it comes from, because hopefully it'll make a little more sense after you understand where it comes from. So if we have a graph of any function, doesn't matter, our graph has a couple of important values associated with it. So the curve would be f of x. It has a start point and an end point. The start point has an x value and a y value. So the x value of the start point, we're going to call that a. The y value, how far up the starting point is, that would be f of a. It also has an endpoint. We'll call the x value of that endpoint b, and the y value of that endpoint will be f of b. Okay, so let's think about what the mean value theorem tells us. It says that if you connect these 2 points with a line, the slope of that line is equal to the slope of the tangent line to a point on the graph that is between A and B. Which, in English, that just means there's another point somewhere on the graph that has a tangent line of the same slope. So let's think a little bit about the equation that we know slope. So we know that slope is represented in math by the letter m, and that's rise over run. Rise means change in y value, and run means change in x value. Change in y value, that means the y value where you end up, which would be f of b on our graph, minus the y value you started with, f of a. Over change in x means the x value of the point you ended up with, in this case it's b, minus the x value of the point you started with, in this case is a. And what do you know, that looks just like the formula for the mean value theorem. So the only thing you need to keep in mind for mean value theorem is that this slope that we just found, f of b minus f of a over b minus a, is the same as the slope of the tangent line to the point. And we know that we find slopes of tangent lines by taking the derivative. So the derivative of f of x at point C is what's equal to the same slope as we found here. F of b minus f of a over b minus a. So that's where the formula comes from. If you ever forget on a midterm or a final or something, I would draw a picture and think about the slope. So let's do an example where we use the mean value theorem. So we are going to do the example f of x equals x cubed over the interval of 0 to 2. Intervals are always written with the squared off brackets, and that just means that the 0 and the 2 are included. So we're looking at x values between 0 and 2. The x value can be equal to 2, and it can be equal to 0. So let's just write down the formula we found. Okay, so f prime of c is what we're solving for, so we don't know what that is. F of b is f of x, which is x cubed, but instead of x, we're at the point b. So instead of x cubed, it'll be our endpoint, 2 cubed minus x cubed, which is f of x, when x equals 0. On the bottom, we'll just have our interval. b is 2 minus a is 0. If we simplify that a little bit, 2 cubed is 2 times 2 times 2, should be 8. Minus 0 cubed is 0 times 0 times 0, would be 0 over 2 minus 0 would be 2. 8 minus 0 is equal to 8 over 2, and 8 over 2 would just be 4, because 8 divided by 2 is 4. So we've found that f prime of c is equal to 4. So the slope of the tangent line at point C equals 4. We want to be able to say the x-coordinate of point C equals some number. So what we do is we look at our original question, f of x equals x cubed. To find f of c, we find all we have to do is replace the x by c. We know what f prime of c is, so let's change this to be f prime of c. So we take the derivative of c cubed, we'll get 3c squared. We found that f prime of c equals 4. So 4 equals 3c squared. If you divide both sides by 3, you will get 4 over 3 equals c squared. To find c all by itself, all you need to do is square root both sides. And you'll get c is equal to the square root of 4 over 3. So the x-coordinate of the point that has the same slope as the slope when the two endpoints are connected has an x value of square root 4 over 3.